So this one is on the graph. So trying to make this bigger. No, too big. All right, so let's do 5. And I'll change it as we go. So Tanner cycled 8 miles in 20 minutes. So I first want you to understand who the x is and who the y. So the time will always be x, your input. And miles goes over here. So we want to find the constant proportionality. So k equals y over x. So in this case, y is the miles. So he did 8 miles. And the x is 20 minutes. And if you divide that, you're going to get a decimal. 8 divided by 20. You're going to get 0.4. So k equals 0.4. And if we change that to unit rate, what does that mean? It's going to be he did 0.4 miles in how many minutes? In 1 minute. And that's your unit rate, right? So let's do a table. So on your table, I'm going to write miles. I'll write minutes, right? So, and I want my equation too. So let me write 1 minute, 2 minutes, 3 minutes. So from that, I can get that the equation is y equals kx, right? But we're going to replace the k with 0.4. You're going to get y equals 0.4x. So that means that every minute he went 0.4 miles. Okay? Not even a full mile per minute. So in 1 minute, you go 0.4. In 2 minutes, 0.8 miles. In 3 minutes, 1.2. And in 4 minutes, 1.6. Okay. Hang on a second. Oh, so now we can graph this. So I'm going to get, let's see, 1, 2, space it out, 3, 4, and this is my minutes. This is going to be my miles. So we're going to go by 0.2, 0.4, 0.4, 0.8, 1.2, 1.6, etc. So you can tell that A is proportional, right? Because it goes through the origin. Okay. That's it. That's all the information. So you need to find k, you need to find the equation. Even though it's not asking you, please do so. Okay. 6. A building is something can build 30 houses in 1 year. How many houses can the company build each month? So the first thing I would probably do is instead of 1 year, I'm going to change that into 12 months because apparently they want the unit rate per month, right? So let's change 1 year to 12 months. So my x is going to be the months, time. My y is going to be the houses. So if I do k equals y over x to find my constant proportionality, I will do y is the houses. How many houses? 30. My x is my time in months, so it'd be 12. So if I divide 30 by 12, I'll get 2.5. That k equals 2.5, and if that means that as a unit rate, these guys build 2.5 houses every 1 month. Okay, so let's take that information, create a table, houses, month. So 1 month, 2 months, 3 months, 4 months, etc., etc. So 2.5 houses in 2 months, they would make 5 houses. In 3 months would be 7.5 houses. In 4 months, 10 months. 4 months, 10 houses. So we can now create a little graph. How months on the bottom, houses on top, and nothing here changes. Okay, 1, 2, 3, 4. Here's going to be 2.5, 5, 7.5, 10. And there we go. That's all we were supposed to do. And I forgot the equation. So the equation would be y equals kx, or y equals k, which in this case 2.5x. And we can use that to find how many houses they built in any amount of months. Okay. Number 7. A trucker drove 171 miles in 3 hours. So we're going to write that the hours is my x. And again, we're doing miles. K equals y over x. My y value given to me here is 171. And my x value is 3. So 171 divided by 3 is 57. So my constant proportionality is 57. So k equals 57. And I can use that to my unit rate, or 57 miles in 1 hour. And that's my unit rate right here. Right. All that information just based on that sentence. So let's create a table. Miles and hours. So I know that's 57 miles in 1 hour. 2, 3, 4, 114 plus 57, 1, I don't know, 57, 171. Yep, 171, and then 228. So again, we can create our little table. Let's stretch this a little bit. No, we can't. So that was spooky. I don't know what's going on. So I don't know how to get rid of this. So I'm just going to write, and hopefully that should disappear. So that's going to be my hours. That's going to be my miles. And that doesn't seem like it's going to disappear. So 0, 1, 2, 3, 4. I don't know why that's not going away. So maybe if I move. So again, 0, 1, 2, 3, 4, and that I think was miles. No, hours. Now it disappears, and then minutes is going to, and miles going to be over here. And I think we went by 57, 114, 171, and 228. So again, it's going to be a straight line. Okay, not all straight lines are going to be like this. It could be a straight line like this. It could be a straight line like this. It really depends on what kind of scale we use at the bottom. Okay, since we're using the same scale, skipping by 2 squares and skipping by 2 squares on the x and the y, so we get a line like that. Okay. 10. He bought 6 bottles of Dr. Pepper for $8.10. So my money, my total, is going to be my y, and my bottles. Okay, so the money, the total that I buy depends on the number of bottles that I buy, right? So my equation is, my constant proportionality is going to be k equals y over x. My y value, do we have a y value? Yeah, y, the money, here is in this case $8.10. And how many bottles? 6. So 810 divided by 6, hopefully it's a nice number. It's going to give us $1.35. So constant proportionality k equals 135. From here, I can write my unit rate, which is $1.35 for every bottle of Dr. Pepper. So that's my unit rate. Here's my constant proportionality, and I can write my equation, which is y equals kx. And then we place k. It's going to be y equals 1.35 times x. So $1.35 times x, which represents however many bottles you want to buy. Let's create a table. Ooh, the table has numbers. Oh, did I mess up on that one? On the previous one? Completely. That's okay. So for this one is bottles on top. And we want to find the total. So if you buy 2 bottles, it's 2 times 135, which is 270. Buy 5 bottles, it's going to be 1.35 times 5, which is going to be 675. If you buy 8 bottles, 8 times 1.35 is going to give us 1.35 times 8 is going to give us $10.80. And if you buy 9 bottles, 9 times 1.35 is going to be $12.15. Okay, so we want to graph this, so I know it's going to be, let's see, 1, 2, 2, 4, 2, okay, let me do the x. On the x, I'm going to do, I'm going by 2, so 2 bottles, 4 bottles, 6 bottles, 8 bottles, 10 bottles. And here I'm going to go, 135, 27, so I'm going to go, this is going to be 135, 2.70, 2.70, be 540. Another 2 is 270 is going to be 810. Another 2 is going to be 270, right? 270 is going to be 1080. Okay, and so forth. So 2 bottles is 270. That becomes right here. That's okay. This is my bottles. This is my money. 4 bottles I don't have, but I have 5. 5 is going to be here between 4 and 6. So, and that's going to be about here. Which is, what's 5 bottles? 675, which is about here. Yep. 8 bottles is 1080, which is right here. And then 9 bottles is here. 9, and it's probably going to be 1215. Right there. Okay, so, oops. Let's draw a better line than that. That's my graph. Okay. Oh, I forgot the equation. So the equation is y equals kx, y equals k, and k we know what it is, 1.35, 1.35x. So every bottle costs me $1.35, and all I have to do is multiply 135 times the number of bottles, and I get my y, which is represents the total amount spent. Okay. So that's it.